Hello, and welcome to Diesel Hub. The following is an animation provided from Ngrain through Virtual Task Trainer, VTT, to demonstrate 16 PC 2.5V main propulsion diesel engine. Measure and record crankshaft web deflections and main bearing clearance.
Note: this is a NAVC modified animation that illustrates key components of the measure and record crankshaft deflection readings procedure. Refer to the appropriate maintenance requirement card, MRC, for detailed step-by-step instructions. Warning: do not open crankcase inspection covers until at least 30 minutes after shutdown of an engine, after a known or suspected crankcase explosion, or overheated part in crankcase. Remove crankcase inspection covers. Install protective screens over drain holes in bottom of crankcase dry sump. Note: sequence shown in this animation is for a counterclockwise engine rotation. For clockwise engine rotation, sequence is right to left. Note: distortion gauge shall be located parallel to crankshaft centerline, 230 mm or 9.055 inches from crankpin. Place distortion gauge between webs of crank throw being measured. Distortion gauge should be compressed approximately 1 to 1.3 mm to ensure that gauge is properly loaded. Bar engine in direction opposite normal rotation to M1 position. Set distortion gauge to plus 0.20 mm graduation. Spin distortion gauge between its centers. Ensure pointer does not move during a complete revolution of distortion gauge. Bar engine in direction of normal rotation, stopping to take readings at positions M2, M3, M4, and M5. Record the readings on the worksheet. Record plus 0.20 mm for position M1. Take reading at M2 position. Take reading at M3 position. Take reading at M4 position. Take reading at M5 position. After recording M5 position, bar engine in opposite rotation back to M1. Distortion gauge must return to plus 0.20 mm. If distortion gauge does not return to plus 0.20 mm, it must be reset and all readings must be retaken. Remove distortion gauge. Repeat the M1 through M5 readings for each crank throw. Crank throw 2 readings. Crank throw 3 readings. Crank throw 4 readings. Crank throw 5 readings. Crank throw 6 readings. Crank throw 7 readings. Crank throw 8 readings. Record all readings on the worksheet. Bar crankshaft until throw is at uppermost position for main bearing being measured. Position the jack saddle on top of the crankshaft and align it vertically between the crank web and the lower cylinder block. Warning: do not use any hydraulic jack other than that specified. A different diameter hydraulic cylinder could provide more force than necessary, causing damage to equipment and injury to personnel. Position hydraulic jack and extension rod on top of saddle and align vertically between crank web and lower cylinder block. Position dial indicator on crank web to be measured. Dial indicator should be next to and parallel to hydraulic jack. An alternate position is to install magnetic base on crank web next to jack saddle and indicate vertically on bottom edge of nearest cylinder liner. Note: hydraulic jack cylinder effective area is 4.439 square inches. At 7,000 psig, a force of 14 metric tons, 31,073 pounds, is applied, 2,205 pounds per metric ton. Warning: do not exceed hose safety limit of 10,000 psig. Apply pressure of 7,000 psig, 14 metric tons, 31,073 pounds of force to crank web. Note: web movements are taken only on free end, FE, of number 1 main bearing and drive end, DE, of number 9 main bearing. Both sides are checked on all others. Record web movement on supplied worksheet. Release hydraulic pressure and remove dial indicator, magnetic base, hydraulic jack, extension rod, and saddle. For purposes of this animation, readings are as follows for the remaining measurements. Free end bearing 1. Free end bearing 2. Free end bearing 3. Free end bearing 4. Free end bearing 5. Free end bearing 7. Drive end bearing 3. Drive end bearing 4. Drive end bearing 5. Drive end bearing 6. Drive end bearing 7. Drive end bearing 8. When all web movements have been recorded, determine each main bearing clearance from graph shown or by formula BC equals M minus 0.03 times 1.375. Record all main bearing clearances, BC, on chart in Figure 6. Check that clearances between cap and saddle are less than 0.001 inches at all 4 corners. Check entire crankshaft line and record all values in Figure 2. 0.001 inches feeler blade should not fit. Check clearances between saddle and block on free end and drive end. You should not be able to fit a 0.001-inch feeler gauge in, except for opposite reference vertical surface closest to parting line. Maximum clearance in this area is 0.0025 inches. Make sure to do both horizontal and vertical for a total of 6 checks for each side of saddle to block mating surface. Check entire line and record all values. Note: if either cap to saddle check or saddle to block check are out of specification, contact NAVSES and NSSA before continuing. Note: clearance must not exceed 0.06 millimeters or 0.002 inches at any main bearing. Caution: ensure no tools or materials are dropped or left in crankcase. Remove crankcase drain protective screens from both ends of crankcase dry sump. Reinstall crankcase inspection covers. Shut all cylinder test cocks. Disengage barring gear. Remove safety tags from diesel engine starting circuit, system in accordance with TUM. Remove safety tags from starting and control air supply valves in accordance with TUM. Remove engine safety tags from ECS in accordance with TUM. Return equipment system to readiness condition. Note: enter all readings into the Shipboard Automated Maintenance Management (SAM) Machinery History module. Note: the Work Center Supervisor records web movement, bearing clearances, and crankshaft deflection readings on the calculation record sheet. Note: calculate and plot corrected crankshaft deflections on the calculation record sheet and the crankshaft deflection graph. Note: record corrected crankshaft deflection readings in machinery history records and analyze readings in conjunction with engine technical manual. Note: determine if corrective actions are required based on acceptable alignment criteria for in-service use listed in the table to the right or significant changes noted in comparison to previous readings.